This video is about the tangent function. This is AP Precalculus topic 3.8. If you appreciate this content, please give it a like. Number 1. A portion of the graph of the function f is shown in the xy plane, where f is the result of a multiplicative transformation of the graph of y equals tangent x. What is the period of f? The period of a tangent function can be measured from asymptote to asymptote, or from midline intercept to midline intercept, whichever is easier. In this case, I think it will be easier to use the midline intercepts, which go from 0 to pi over 2. So the period is simply pi over 2. Number 2. The function g is given by g of x equals 2 plus 4 times the tangent of 3x. What is the period of g? We have learned that the period of a tangent function is always pi divided by the b value. And in this case, the b value is 3. So that's it. The period is pi over 3. Number 3. The function m is given by m of theta is equal to negative 2 times the tangent of theta over 4. What is the period of m? Theta over 4 is the same thing as 1/4 times theta. Written this way, it's easier to see that the b value is 1/4. And as I just mentioned, the period for a tangent function will always be pi divided by the b value. In this case, pi divided by 1/4. When you divide by a fraction, you multiply by the reciprocal. So we have pi times 4. In other words, the period is equal to 4 pi. Number 4. The function h is given by h of theta equals the tangent of pi over 2 times theta. What is the period of h? Well, for a tangent function, the period is going to be pi divided by the b value. In this case, the b value is pi over 2. When you divide by a fraction, you multiply by the reciprocal. So the period will be pi times 2 over pi. The pi's will cancel out because we have one high and one low, leaving the period is equal to 2. Number 5. The function k is given by k of x equals the tangent of x minus 2 pi. What is the period of k? Well, we know that the period of a tangent function is always pi divided by the b value. There is no number that is visibly multiplying in the front. That means the b value is 1. So the period is simply pi. Number 6. The function j is given by j of x is equal to 4 plus the tangent of x over 2. Which of the following gives the vertical asymptotes of j? The vertical translation by 4 will not affect the position of a vertical asymptote, so I can ignore the 4. I'm putting this part in a thought bubble because this is not something you need to be writing down. But you should be thinking, the tangent of x over 2 is equal to the sine of x over 2 divided by the cosine of x over 2. A vertical asymptote will occur where tangent of x over 2 is undefined. That's going to be where the denominator, cosine of x over 2, is equal to 0. So the first thing you actually need to write down is this equation. We need to find where the cosine of x over 2 is equal to 0. First, we solve for x over 2 by asking ourselves the cosine of what is equal to 0. On the unit circle, cosine is the x value, and x values are equal to 0 here and here. So we have one solution at pi over 2. And yes, the next solution is down here at 3 pi over 2. But I'm not making a list. I need to write an expression for the infinitely many solutions to this equation. So I'm going to recognize that the next solution is going to be pi radians after the first solution. And in fact, if I go another pi radians, that takes me back to where I started from, and that gives me another solution. So every time I go pi radians, I'm going to get a solution. So I can get more solutions by adding multiples of pi. That's why I'm going to put plus pi k, where k represents any integer. We need to still get x by itself, so let's multiply both sides of the equation by 2. Multiplying by 2 on the left leaves x. Multiplying pi over 2 by 2 cancels out the 2 and leaves pi. And multiplying this last term by 2 gives us 2 pi k. Let's look for this among the options, and we see that the answer is B. Number 7, the function f is given by f of x is equal to the tangent of 4x. Which of the following gives the vertical asymptotes of f? You should be thinking the tangent of 4x is equal to the sine of 4x over the cosine of 4x. A vertical asymptote will occur where tangent is undefined. That's where the cosine of 4x is equal to 0. So we need to solve this equation. The cosine of 4x is equal to 0. We begin by solving for 4x by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are 0 here and here. We start with the pi over 2 on the top. We need infinitely many solutions, so next we recognize that from one solution to the next is always a difference of pi radians. So we are going to add multiples of pi to get the infinitely many solutions. So plus pi k, where k is any integer. Now we need to isolate the x by dividing everything by 4. Dividing 4x by 4 just leaves x. Pi over 2 divided by 4 is pi over 8. And then pi k over 4 is pi over 4k. So I'm just looking for that, and we see that the answer is A. Number 8, the function g is given by g of x is equal to the tangent of 2 pi x. Which of the following gives the vertical asymptotes of g? You should be thinking the tangent of 2 pi x is equal to the sine of 2 pi x over the cosine of 2 pi x. Vertical asymptotes will occur where the tangent of 2 pi x is undefined. That's going to be where the cosine of 2 pi x, the denominator, is equal to 0. So we need to solve the equation cosine of 2 pi x is equal to 0. We begin by solving for 2 pi x by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So we have our first solution up top at pi over 2. We will get to another solution every time we add pi. So by adding multiples of pi, we will get an expression for the infinitely many solutions. So we will add pi k, where k is any integer. We need to get x by itself by dividing every term by 2 pi. So I have to divide this by 2 pi somehow, and 2 pi. When you divide a fraction by something, the thing you are dividing by ends up in the denominator, multiplying. So the 2 pi's will cancel out on the left, leaving x by itself. But pi over 2 divided by 2 pi will be pi over 4 pi. Okay, again, when you divide by 2 pi, you really multiply the denominator by 2 pi. These pi's cancel each other out, leaving behind k over 2, but I would rather write this as 1/2 k. Maybe I'll just do that on the next step. So we have x equals. These pi's will cancel each other out, leaving behind 1/4. And then let's write this as 1/2 k. Now let's look for this among the answer choices. 1/4 plus 1/2 k. So the answer is C. Number 9. The function h is given by h of x is equal to the tangent of x minus pi. Which of the following gives the vertical asymptotes of h? You should be thinking the tangent of x minus pi is equal to the sine of x minus pi over the cosine of x minus pi. A vertical asymptote will occur where the tangent of x minus pi is undefined, which is where the cosine of x minus pi is equal to 0. So we need to solve the equation. The cosine of x minus pi is equal to 0. First, we solve for x minus pi by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So the first solution is pi over 2, and then we recognize that we will get another solution every time we add pi. So we can get infinitely many solutions by adding multiples of pi. So we will add pi k, where k is any integer. Now we need to isolate the x by adding pi to both sides of the equation. So this is going to be x is equal to pi over 2 plus pi plus the pi k. Let's do like denominators right here by writing pi as 2 pi over 2. That will give us x is equal to 3 pi over 2 plus pi k. Let's look for this among the answer choices. Let's see, there it is, 3 pi over 2 plus pi k. So the answer is D. Number 10. The graph of the function f is given in the xy plane. If f of x is equal to a times the tangent of bx, where a and b are constants, which of the following is true? Well, we see that the waves are sort of increasing from left to right. That means this is a right side up tangent function compared to the parent function, so the a value will be greater than 0. That narrows it down to either options A or B. We can eliminate C and D. To figure out whether the B value is less than 1 or greater than 1, let's find the B value. But we need to start with the period. The period can be measured from asymptote to asymptote, or from point of inflection to point of inflection, whichever is easier. Since this point of inflection is at 0 and the next one is at 4 pi, the period is 4 pi. We know that the b value will be pi divided by the period for a tangent function. So that's pi divided by 4 pi. The pi's will cancel each other out, leaving a b value of 1/4. This is less than 1, so the answer is B. Number 11. The graph of g is given in the xy plane if g of x is equal to a times the tangent of bx, where a and b are constants. Which of the following is true? Since g is decreasing from left to right, we know that this tangent function is upside down compared to the parent function. So the a value is less than 0. The a value is negative. we can eliminate options A and B. To figure out whether the b value is greater than 1 or less than 1, let's find that b value. But first we need the period. The period can be measured from asymptote to asymptote. From negative 4 pi to positive 4 pi is a total of 8 pi. So the period is 8 pi. Now the b value for a tangent function is given by pi divided by the period. The pi's cancel out, leaving a b value of 1/8, which is less than 1. So the answer is D. Number 12. The graph of the function h is given in the xy plane. If h of x is equal to the tangent of b times x plus c, where b and c are constants, what are the values of b and c? So to find the b value, we start with the period. The period can be measured from asymptote to asymptote. Since we have one asymptote at 0 and the next asymptote at pi over 2, the period is pi over 2. Now the b value is given by pi divided by the period for a tangent function. So that's pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So b is equal to pi times 2 over pi. The pi's cancel out because we have one low and one high, leaving b is equal to 2. With this b value, we have narrowed it down to option C or D. We can eliminate A and B. So now we need to find the C value. The C value is the opposite of the phase shift, and the phase shift is always going to be one of these points of inflection. So if the phase shift is negative pi over 4, then the C value is going to be positive pi over 4. If the phase shift is positive pi over 4, then the C value will be negative pi over 4. Let's look for either one of these two C values. We see the negative pi over 4 right here, and option D doesn't have either one. So the answer is C. Number 13. The graph of the function k is given in the xy plane. Which of the following could be the expression for k of x? Well, first of all, this function is decreasing from left to right. That means we have a negative a value because this is upside down compared to the parent function. Only options A and D have this negative a value, so we can eliminate B and C. I notice that options A and D have different b values, so let's calculate the b value and see which one is a match. We need to start with the period, which can be measured from asymptote to asymptote. From negative 2 pi to positive 2 pi is a total of 4 pi, so that's the period. The b value will be given by pi divided by the period for tangent functions. The pi's cancel out, leaving a b value of 1/4. This corresponds to answer choice D. Number 14. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is 1. Which of the following could be the measure of angle theta? The terminal side with a slope of 1 goes right through the middle of the first quadrant. This is pi over 4, so this is one angle where the slope of the terminal ray is 1. But, that is not one of the answer choices. Well, the slope is also 1 in the exact opposite direction. So the question is, what is the measure of this angle? We know that pi is right here, and we can think of pi as 4 pi over 4. So this angle will be 1 pi over 4 past 4 pi over 4. So this is 5 pi over 4. So the answer is C. By the way, at the beginning of this problem, I instinctively knew that a slope of 1 looks like this. It would go right through the middle of the first quadrant. This is the 45-degree angle that we learned about back in geometry class, but now we call it pi over 4. If you did not automatically know that the way I did, I can explain it one different way. You need to memorize the 9 trig values on this chart. So if you have not already done so, please pause the video and study the chart right now. The tangent of an angle is equivalent to the slope of the terminal side of that angle. So when they told us that the slope of the terminal ray is 1, they were telling us that the tangent is 1. So the question became the tangent of what angle is 1? And if you have memorized these 9 facts, you know that the tangent of pi over 4 is 1. So that's another way we could know that the reference angle is pi over 4. And then you go from there as I did before. Number 15. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is 0. Which of the following could be the measure of angle theta? A horizontal line has a slope of 0. So we get a slope of 0 at an angle of 0 radians, but that's not one of the choices. As we rotate around the circle, the next time we get to a horizontal position is right here at pi, but that's not one of the answer choices either. To get horizontal again, we have to rotate all the way around and back to where we started from. That is 2 pi radians. So the answer is D. Number 16. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is 1 over radical 3. Which of the following could be the measure of angle theta? Tangent theta is equivalent to the slope of the terminal ray of angle theta. So if the slope of the terminal ray is 1 over radical 3, that means the tangent of theta is equal to 1 over radical 3. We can use our memorized facts to identify the reference angle, the tangent of which angle is 1 over radical 3. We know that the tangent of pi over 6 is 1 over radical 3. So that means pi over 6 is the reference angle. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 6. There's one in every quadrant. However, we can quickly narrow it down to 2 angles because we're told that the slope is positive 1 over radical 3. Notice that the terminal sides in quadrants 1 and 3 have positive slopes. They go uphill from left to right. On the other hand, the terminal sides in quadrants 2 and 4 have negative slopes. They go downhill from left to right. Because we are looking for a positive slope, we can forget about quadrants 2 and 4. The angle in the first quadrant is pi over 6 itself, but pi over 6 is not one of the options. So it must be the angle in the third quadrant. What is this? Well, since pi is right here, and we can think of pi as 6 pi over 6, we know that this angle will be pi over 6 more than 6 pi over 6. So this angle is 7 pi over 6. So the answer is D. The tangent of 7 pi over 6 is 1 over radical 3. So that's the slope of the terminal ray. Number 17. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is negative radical 3. Which of the following could be the measure of angle theta? If the slope of the terminal ray is negative radical 3, that means the tangent of angle theta is equal to negative radical 3. If we ignore the negative sign for a moment, we can discover the reference angle. The tangent of what angle is equal to radical 3? Well, we have memorized that the tangent of pi over 3 is radical 3. So pi over 3 is the reference angle. There is an angle with a reference angle of pi over 3 in every quadrant, but this time I'm only going to draw the two angles that have a terminal side with a negative slope. We want the tangent to equal negative radical 3, so the slope has to be negative. By the way, the reference angle is the angle between the terminal side and the x-axis. So this reference angle of pi over 3 is right here and right here. One of these two angles will be the answer. Let's find this angle. Since pi is right here, and looking at the reference angle, we can think of pi as 3 pi over 3. This angle will be pi over 3 less than 3 pi over 3. So this angle in the second quadrant is 2 pi over 3. So this is one possible answer. Let's look for it. Nope, 2 pi over 3 is not among the choices. So let's move on to the angle with a terminal side in quadrant 4. Well, pi is the same as 3 pi over 3. If we double that, we find that 2 pi is the same thing as 6 pi over 3. Therefore, this angle is pi over 3 less than 6 pi over 3. So this is 5 pi over 3. Is that among the answer choices? Yep, the answer is C. Number 18. In the xy plane, an angle theta is in standard position with a measure of theta equals 3 pi over 4. Which of the following is true? All of the options simply state the slope of the terminal ray of angle theta, but we know that the slope of the terminal ray of angle theta is equal to tangent theta, and we are given that theta is 3 pi over 4. So the slope of the terminal ray of angle theta will equal the tangent of 3 pi over 4. First of all, in what quadrant is 3 pi over 4? Pi is right here, and we can think of it as 4 pi over 4. Therefore, 3 pi over 4 is pi over 4 less than 4 pi over 4. That puts it right here in the middle of the second quadrant. Notice that the slope of the terminal side is negative. So the tangent of 3 pi over 4 will be negative something. So we can eliminate options B and D, which have positive slopes. We also know that the reference angle is pi over 4. The reference angle is right here between the terminal side and the x-axis, and 3 pi over 4 is exactly pi over 4 less than 4 pi over 4. So that is the reference angle. This is helpful because the tangent of the reference angle will be equivalent to the tangent of 3 pi over 4, except sometimes the sign will be negative. We have memorized these 9 trig facts, including the fact that the tangent of pi over 4 is 1. We already know that the tangent of 3 pi over 4 is negative, so now we know it is negative 1. So the answer is C. Number 19. In the xy plane, an angle theta is in standard position with a measure of theta equals 4 pi over 3. Which of the following is true? Again, they are all just saying the slope of the terminal ray of angle theta. That means the tangent of theta. And we are given that theta is 4 pi over 3. So we're talking about the tangent of 4 pi over 3. To locate the quadrant of 4 pi over 3, we think of pi as 3 pi over 3. Therefore, 4 pi over 3 will be 1 pi over 3 more than 3 pi over 3. That puts it into the third quadrant. We can see that the reference angle is pi over 3. So the tangent of 4 pi over 3 will be the same as the tangent of pi over 3, except we have to be careful of the sign. We have memorized that the tangent of pi over 3 is radical 3. So the answer is either radical 3 or negative radical 3. In the third quadrant, we can see that the slope is positive. So the tangent of 4 pi over 3 is positive radical 3. So the answer is D. Find the exact values of the following expressions if possible. In what quadrant is 5 pi over 6? Well, pi is right here, and we can think of it as 6 pi over 6. Therefore, 5 pi over 6 will be pi over 6 less than 6 pi over 6. It'll be right here. In this quadrant, the slope of the terminal side is negative. See how it goes downhill? So we know that the tangent will be negative something. We can also see that the reference angle is pi over 6. We have memorized that the tangent of pi over 6 is 1 over radical 3. So the answer is negative 1 over radical 3. Or we could say negative radical 3 over 3. Number 21. In what quadrant is 7 pi over 4? Pi is right here, and we can think of it as 4 pi over 4. Doubling this, we can think of 2 pi as 8 pi over 4. Now we can see that 7 pi over 4 is 1 pi over 4 less than 8 pi over 4. That puts it right here in the fourth quadrant. Notice that the slope is negative. It's downhill from left to right. So the tangent is negative something. We also see that the reference angle is pi over 4. We have memorized that the tangent of pi over 4 is 1. So the answer is negative 1. We will not need our memorized facts for number 22 because 3 pi over 2 doesn't land in a quadrant. The terminal side falls right on the negative y-axis. Because this is a vertical line, the slope is undefined, so the tangent is undefined. In what quadrant is 4 pi over 3? Well, we can think of pi as 3 pi over 3. So 4 pi over 3 is 1 pi over 3 past 3 pi over 3. That's in the middle of the fourth quadrant. Notice that the slope is positive. So tangent will be positive something. We see that the reference angle is pi over 3. And we have memorized that the tangent of pi over 3 is radical 3. So the answer is radical 3. The tangent of pi over 6 is one of our memorized facts. So it is 1 over radical 3. Or you could say radical 3 over 3. 0 is the starting point. This is a horizontal line, and horizontal lines have a slope of 0. So the tangent of 0 is 0. When an angle is negative, it means rotate in the clockwise direction instead of the usual counterclockwise direction. So starting from 0, if we rotate this way, negative pi is halfway around and to here. All that matters is that the terminal side is horizontal, and a horizontal line has a slope of 0, so the tangent is 0. We have memorized that the tangent of pi over 4 is 1. I'm going to demonstrate the location of 13 pi over 6 in two ways. First of all, pi is right here, and we can think of it as 6 pi over 6. We can think of 2 pi as 12 pi over 6. Therefore, if we go all the way around and to here, so far we have gone 12 pi over 6. 13 pi over 6 will be 1 pi over 6 past this. So that's going to put it right here in the first quadrant. In the first quadrant, the tangent is positive. The slope is positive. So we know that it will be positive something. And the reference angle is pi over 6 because we are pi over 6 past 12 pi over 6. And the tangent of pi over 6 is 1 over radical 3. So the answer will be positive 1 over radical 3. Or you could put radical 3 over 3. Another way to process this is to simply recognize that 13 pi over 6 is bigger than 2 pi. It's bigger than 12 pi over 6. Subtracting 2 pi will not change the value of any trig function. And subtracting 2 pi is the same thing as subtracting 12 pi over 6. 13 pi over 6 minus 12 pi over 6 is simply pi over 6. That means the tangent of 13 pi over 6 is the same as the tangent of pi over 6. And that is one of our memorized facts, which is 1 over radical 3. So that's another way you can think about it. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.